In this video, we'll be looking at section 6.2, and this is solving special right triangles using similar triangles. So this will be our, what did I say, 6.2? 9.2. So this will be our segue into right triangles. So we're going from similar triangles, using this as a stepping stone into right triangles, and these are special right triangles, and then we'll move into our um, just more freedom within right triangles. So this is just two very special cases. So there are two types of special rectangles. So these two types are right here. We have number one will be our 45, 45, 90. And this is our angle measurement, so degrees. 45 degrees, 45 degrees, 90 degrees. And then we'll have our, over here, we'll do our 30 degree, 60 degree, 90 degree. So the 30, 60, 90. And so when we're given a right triangle, this is what we need to draw and have memorized. So if I have a 45, 45, 90, it'll look something like this. So we have this right angle right here. So there's our 90 degree. And we'll be told that this is 45 degrees and this is 45 degrees. So we'll see this in our problem, the 45, and we'll know that we're looking at a similar triangle to this one. And this is what we need memorized. This side length is always 1, this side length is always 1, and this side length is root 2. So this is the triangle we use as a similar triangle. For 45, 45, 90. Okay, so now we have a different triangle, and this one's 30, 60, 90. So it'll look something more like this. It's going to be 30, 60, and then our right angle right here is our 90. Now the key to this is identifying what's across from it. So across from the 30 degrees, if I look across it, I'm just drawing like a dotted line. Across from the 30 degrees is my side length 1. So across from 30 degrees is side length 1. And then across from the 60 degrees, if I look across from the 60 degrees, this side length will be root 3. So across from 60 degrees is side length square root of 3. And then across from our 90 will be side length just a 2, normal 2. So across from 90 degrees is side length 2. And that's the triangle we'll use when we're doing our similar triangles for 30, 60, 90. Okay, so what we're doing right now is we are identifying that this is what we need to have memorized right here. For when I see 45, 45, 90, I need to be able to draw this triangle on my own. It's not given to us. We have to draw it and then use our similar triangle abilities to create our proportions. So let's see what that looks like. So we'll do some examples. So we're going to use these two triangles depending on our situation. So for example 1, I'll be given a triangle that looks like this. And I'm told that's that, and that's 45 degrees. And we're looking at y. We're looking at this. So this is how the problem's given. That's all I'm given. And I'm like, okay, how do I figure out what y and x equal? Well, what we can do is draw our 45, 45, 90 triangle and set up our proportions. So I'm going to draw that triangle first. So since I did it in blue, I'll do it in blue again. Now what I like to do is make sure when the one I'm drawing is orientated the same way. So I'm not copying it right from my notes, I'm spinning it. So picture it like in our notes, we have it kind of like this, 45, 45, 90, but I'm going to write it on my paper so that it's spun the same way as the problem I'm looking at. So now this is 45, 45, 90. And then if I look back to my notes, I can see that this is length 1, this is length 1, and this is root 2. So now that I have it drawn the same way, I can actually use this kind of matching up the sides by where they're located. So my left-hand side matches with my left-hand side, right to right, bottom to bottom. And we'll build our proportions. So let's do for y first. So I'll go y is to 1. So y over 1 is equal to, so I just did left side is to left side is equal to right side to right side. Now I chose these sides because I need to use this 6 to 1. I have to use the 6 to 1 because that's given. That's the only ratio that I can build where it has both numbers. So I got to make sure one of my ratios has two numbers, otherwise this won't work. But now we can cross multiply and solve. So 1 times y is y. And then 1 times 6 is 6. And I found what y equals. Y equals 6. Okay, now let's set it up for the x. So we'll go x is the square root of 2. As, now I'm going to go, so I went bottom is to bottom. Now I'm going to go as right is to right. Now we cross multiply and solve. So I'll do 1 times x is equal to 6 times root 2. Remember, this is kind of like that idea I have the hidden 1 out front. So I need to multiply 6 times 1 root 2, and that gives me 6 root 2. X is by itself, and we're done. That's how we're going to do it. We're given this triangle in black, and then the rest in blue is what we have to come up with. I drew this from my notes. I will always use this triangle when it's a 45, 45, 45, 90. And then I will then use this triangle in blue to help me set up my ratios and my proportions. Okay, let's look at one that is a 30, 60, 90. So our problem will be given to us, and it will look something like this. And then we'll be told this is 30, and then we're given 16x and y. So the same concept. I don't want to copy it straight from my notes. I want to draw my similar triangle that is drawn the same way. That way it's easy to match up using the picture. Top is the top, right is to right, bottom is to bottom, something like that. So I'm going to draw this just like this one. So they're spun the same way. Okay. And I can't stress this enough. All that's given to me to solve is this black triangle. I have to build the rest. So I'm going to draw in my right angle. This is my 30, and this must be my 60. And now we can fill in using my notes. Well, across from the 30 was, let's go back to my notes. Across from 30 was 1. So across from 30 is the measurement 1. Going back to my notes, across from 60 was the square root of 3. And then across from the 90 was the length of 2. Now that we've drawn our similar triangle, we can use our proportions to set up our equations and solve. So I'll start with x this time. So I'm going to go x is to root 3 as 16 is to 2. Remember, I have to use the 16 to 2 because that's where I have two numbers. I do not want to. Okay, this is a do not. If you do this, go ahead and scratch it out, and then you can just start over. If you end up with two variables, say you did x is to root 3 as y is to 1, I just can't solve. I can't figure out what x or y equals. Because if I did the square root, so I'd have y square root of 3 equals 1 times x is x. And I'm just not going to get anywhere. I'm just stuck with this x and y. So if you have both variables, this is not going to work. So don't do this. We want to make sure we have one variable and the rest numbers. So I'm going to go x is to root 3, bottom is to bottom, as, and then since here are my two numbers, I'll go hypotenuse is to hypotenuse. 16 is to 2. Now we cross multiply and solve. 2 times x is 2x. Root 3 times 16 is going to be 16 root 3. I'm solving for x, so I divide by 2, divide by 2. The numbers on the outside of the square root we can divide, so I get x equals 8 root 3. We draw our similar triangle, we set up our proportion, we solve. Okay, so let's try that again, but now we're going to solve for y. So I'm going to go y is to 1, my right-hand side to my right-hand side. Y is to 1, as, got to use my numbers, so I'm going to go 16 is to 2. Cross multiply and solve. So I get 2y equals 1 times 16 is 16. Divide both sides by 2, and we get y equals 8. And that's how we can use our special right triangles to help us solve using while also using our similar triangle skills, setting up those proportions. So thank you very much for watching this video, and I hope you have a great rest of your day.